we want to define a function that determines whether two strings are anagrams of each other. Well, what's an anagram? Well, Google knows. If you type in anagram, you're going to get, did you mean Nagaram? And Nagaram actually happens to be an anagram of anagram, which is, I think, quite ironic. So Google's having a little fun here, obviously, but basically an anagram is a word that can be rearranged, a word that can be created by rearranging the letters of another word. So that's the key idea here. And then also we have an extra challenge, which I'll also go over. Can you write this function in one line? So this seems pretty hefty, because it seems like there's a lot of work to do to figure this out. But turns out that there is actually a very, very clever solution to this, and it's super cool. So anyway, let's look at this. So I'm going to first go through a very standard way to do this type of problem. And it's going to use dictionaries, because what the key idea, why are we using dictionaries? Well, we need to keep track of characters, because at the end of the day, an anagram is going to have the same count of characters. So for example, cinema is an anagram of Iceman. Cinema and Iceman have both only one C. They have only one I shared. They have one N, they have one E, they have one M, and they have one A. So in this case, they all have only one letter in common. Sorry, every single character occurs once in both words. So basically, we need to keep track of character counts. And if you remember from our previous exercise, we have figured out how to do that. So that's going to come into play here. But let's look at some more examples. We have is anagram on listen and silent, which returns true, and some more examples of anagram and what's not an anagram. So now, once we have that, I like to again think of very simple cases. What do we know for sure is not going to be an anagram? Well, let's look at this example. Why is grades and intelligent not an anagram? Well, we already know it's for sure not going to be an anagram because intelligent has more letters than grades. So the key idea here is to notice that if the length of my first string does not equal the length of my second string, I'm basically done. That I know for sure that it's not going to be an anagram. So that's the key idea here. And now, what we're going to do is we're going to find a way to track characters now. So what we're going to do is we're going to define the dictionary, and once we've done that, remember from one of our previous examples is we basically go through every single letter in one of the strings, and we're going to find a way to track it. So if the letter is not in the dictionary, in my dictionary, I'm going to create a key and an associated value with it. So what's the key? The key is going to be the letter, and if I haven't seen the letter yet, what's the count of this letter? It's going to be 1 because that's the first time I've ever seen it. And then otherwise, I know I've seen this letter before, so I basically go into the dictionary, find my letter, and increment it. So here's the character tracker idea that we've done before. So now what do we do? Well, we have to make sure that the second string has the same count of characters as the first. What's a way we could do that? Well, maybe we could do the same character tracker and see if the dictionaries are the same, but that seems kind of complicated. Why don't we just take the same dictionary and then go through every single letter, and if the letter's in the dictionary, we can just decrement it, and by the end of it, it should be 0. Everything should be 0 because they have the same counts, right? So that's the key idea here. So, for example, I'm going to have 1 C initially when I go through cinema, and then when I go through Iceman, because I have 1 C, I'm going to decrement 1 from the C count, and that will be 0. And then same with all the other letters. And at the end, I know that if everything's 0, I know for sure that it's an anagram. And also, so let's just go through this idea. So for every character in my second string, if the character is not in my dictionary, what does that mean? Well, what that means is that there's a character in this string that's not in this string. And that immediately means that this is not an anagram. Because anagrams have to have the same characters for all letters. Same characters throughout for the entire word. Alright, now, if it is in there, which it should be, if it's an anagram, we just decrement the associated value at that character. And now, once we've done this, we basically have some formation of the dictionary where both words went through, and did their modifications. And if it is an anagram, I know for sure that the dictionary should have values of all 0 because they should share the same amount of characters and the same characters overall. Okay, so how do we check if the dictionary has all values associated with 0? Well, we go through every single key in the dictionary, and if it's the case that the value associated with that key is not 0, then I know that it's not an anagram. So why do I know this? Because if, for example, if this had an extra C, then the count on the C character key would be -1 because this would have one more C than this. And then because of that, I know for sure that this cannot be an anagram. Okay, and then if I go through all of this and it finds a way to pass through all of this, I know for sure it's an anagram. And that's my general logic here. So let's test this. So this is a lot of code for this. So it's very good to have these tests. So let's make sure it works, and it works. Awesome. So here, I think this is the first time we've ever defined 3 for loops in one function, but it's what's necessary to do this type of function. So it's a little challenging. But now, this problem states that we can write this in one line. Is that even possible? How many lines do we use? We use 51 through 68. We use 19 lines for this problem. Okay. There's no way we could do this in one line, right? Wrong. We actually can do this in one line. And it's very, very, very clever. So if you could figure this out, props to you, because this is not easy to figure out. So let's go. So this is a clever way to define is anagram. And honestly, there's really no other way to explain it but to give you the intuition behind it. If I have 2 words that are anagrams, that means that they have the same letters, basically. So if I sort this word and I sort this word, they should be the exact same word. And that's the key idea here. And that's hard to see. So then the question becomes, see, for example, if I sort listen and I sort silent, so let's check this out. So I'm going to just run Python, and we're going to have 2 strings, listen and silent. S2 is silent. Silent. Okay. And so how do I sort something? I have this function called sorted. What it does is it returns a list. Okay. So we want to sort it in terms of strings. So how do we sort it in terms of strings? Well, the way we do that is we use something called the join function, and we basically take this empty string and we join it with every single, I think we've briefly seen the joins function, but here's an example of the sorted version of S1. And we get this, as we can see. So now, what happens if we do the same thing? So we take our empty string and we join it with the sorted version of S2. We get the same thing. So here's the key idea. If we sort these strings, they should equal the same thing if they're an anagram. And if it's not an anagram, they shouldn't equal the same thing. So we can actually define this in one line. So let's look at that. So we just want to return true or false, so we just check if the empty string joined with the sorted version of our string, S1, is equal to the sorted version of string 2. Okay, and let's check this out. So, unbelievably, it's gonna work. So, so the amazing thing here is we took something that took us 19 lines to define and compressed it into one line. So, always be on the lookout for really clever solutions. And personally, I think these solutions, I find them very cool because we just took all of this, we put so much effort into this, but this solution is just like kind of laughing at us, like, wow, here I was the entire time. And I think this is one of the best solutions to this problem. So always be on the lookout for clever or better ways to do things. And one thing I like to do is whenever I write a piece of code, I always ask myself, hey, is there any way I could do this better? So, and sometimes if you spend some time and figure out a better way, you can actually end up learning something from the problem. So as you can see here, this is a very clever way to define a function that tells if something's an anagram with another string. So anyway, that's all I got for today. I hope you found this really cool. I'll see you next time.